talk about visual-spatial abilities. So with regard to visual-spatial ability, one of the biggest things that I like to look at is the Boston approach, how we're going to be doing things. But we'll talk about that in just a second. And maybe we'll talk about that. Okay, visual-spatial ability, aka visual-spatial. You might also see visual constructional or visual motor. These are all kind of used interchangeably, though they do measure different things. Certainly motor ability, hand-eye coordination, it measures that. Visual is your ability to see and perceive. Visual-spatial and visual constructional is how you're putting things together, but sometimes they're used interchangeably. One of the ways to administer a complex figure is to administer it with different colored pencils. Right. Can everyone see that, or should I pass it around? Yes. All right, so as we see, Miss Mancusi started with the green box. She started green, and then she started filling in the details. Purple up here, and then she ended with brown. All right. This is a good example of a Gestalt approach, meaning that she organized it in a very healthy way, a very efficient way, by starting the box first and the main X or plus sign in the middle, so that then she can start filling in the details. Now, there are three different ways that people organize information. There's the Gestalt approach. There's a detailed approach. A detailed approach might be they start with a box and then they do the outside details. Okay. And then there's something called a stimulus-bound approach. A stimulus-bound approach is they start here and they start going over here and they just kind of follow it around. And then they kind of get excited and do some stuff in the middle. And they don't have an organized strategy for organizing visual information. Now, their Ray complex figure drawing, it's an actual test that you can purchase, suggests that you do not use the colored pencil approach of administration. The RBANS also has a complex figure drawing, and it's just like this. They say, please draw this figure. So you say, please draw this figure. And hope that they time it well. Now you can use this colored pencil approach or administration of the test with the RBANS. It doesn't suggest not to. With the Ray, they actually have a space that you can draw along with the person and watch how they're drawing it, so you can use colored pencils on yours. That's another way of administering it, where you're actually drawing along with them and putting notations as to what their approach is. Right. So there's no right or wrong way of doing it if you don't have instructions that tell you not to. The trails is also a visual-spatial visual motor test. It looks at psychomotor sequencing, visual tracking, scanning, speed of mental operations, and motor speed. The WACE has block design, digit symbol. And block design looks at visual-spatial, whereas digit symbol is more psychomotor speed. The block design has also constructional abilities. Now, the clock, which we're going to talk about in a second, there's something called clocks, C-L-O-X. All you have to do is Google it, and you can find all of the information with regard to it. It's a means of administering the clock drawing task. Clock drawing task is an excellent way of looking at visual-spatial, visual motor. Also, Ray and RBANS have the figure copy that we just talked about, and the bender to the lesser extent. Now the RBANS, we just talked about figure copy, it also has line orientation. Line orientation looks like this. You have two lines, and you say, which two lines up here match the two lines down here? And you ask them to tell you the two lines that they match, the number of the lines that they match. And this actually isn't from the RBANS, because that would be copyright laws. This is just something I found online from the 1980s, so apparently they included that. Now, to interpret line orientation, I mean, it's obvious if someone has hema neglect and they don't see this half. They might just say, oh, there are no lines there. That's easy enough. And if they have dyslexia, maybe there's some reversals, all right? But I wanted to go deeper. I'm like, this test must have a lot more to it. So I actually wrote the creator of the RBANS. I emailed him and I said, what does this test actually get at, aside from possible hemi-neglect, maybe the dysfunction of dyslexia? He wrote back 2 words: visual-spatial. So there it is. If they have deficits in line orientation, you can interpret that means they have problems with visual-spatial ability. Yeah. As per the creator of RBANS, who, by the way, is very approachable. You can email him all. More extensive visual-spatial tasks can be seen in the Beery, the bent facial recognition, the Hooper, the NAB. There's other tests that are out there that give you more information with visual-spatial. Let's see, both hemispheres of the brain are used to realize designs. Patients with lateralized lesions tend to make errors on the side of the design that's contralateral to the lesion. So that means if they have a lesion on this side, they're going to make deficits on their right side. They're going to have deficits on their left drawing of figures or block design. But in general, any type of brain impairment, you can expect lower block design scores. And in Alzheimer's patients, block design is strongly associated with the atrophy of the right parietal region. Patients with right-sided lesions often work from right to left, whereas unimpaired people usually work from left to right because that's how we read. So that's another qualitative thing that you can think of when you're paying attention. Unless they come from a country where they read from right to left. In general, if they have grown up in a country that reads from right to left, then don't take that qualitative observation into account.
Okay.
Yes. So thank you for bringing that up. That was actually in my notes somewhere.
Okay.
Now, broken configurations for block design, if they break the gestalt and instead of having the 4 blocks or the 9 blocks, broken the gestalt. I don't know if anyone has had that happen. It's the freakiest thing when it does. You're sitting there saying, wait, no. That's indicative of a right parietal lesion. Something's going on. Or some damage in the occipital area, right? As we just found out because Mr. Cartwright read it. Anytime you're trying to figure out the nuances of these tests and how to interpret them, look in LASIK because it will tell you. So the Bender Gestalt is developed in 1938, Bender Visual Motor Gestalt Test. It's one of the most widely used tests. It's supposedly co-normed with the Stanford-Binet scales. It's normed for ages 3 to 85, and actually the Stanford-Binet 2, I'm sorry, the Bender Gestalt 2 is out. It does have a memory component to it, and it's also a good screening test, though I'm not really fond of it considering I can have other tests like the RBANS and clocks that can. Hey, so you remember that figure I had you draw a few minutes ago without looking back in your notes?
Oh.
Draw that figure now, will you? This is actually how you would administer this test. You would administer the first part, go on to do something else, usually verbal in nature. Probably not a good thing to do another visual thing. And then come back to it. Let's all draw a clock. Grab another piece of paper. See our visual-spatial things fun. I would like you, please, now to draw the face of a clock with all the numbers on it. Please make it large. All right, now draw the hands at 20 to 4. All right, so this is a great test qualitatively to pay attention because many people will start drawing the time even though your instructions were only draw the face of a clock with all the numbers on it and make it large. So that's something to know. And then draw the hands at 20 to 4. Were they actually able to draw the hands at 20 to 4? Yeah. As opposed to something else. Yeah, you want to know if the person's impulsive, they're getting ahead of you. If they write the wrong time, you said 20 to 4. Did they put 4:20?
What did they?
Some people are like, oh.
What
If they say, that's the second part, you're watching them draw the clock. So once they've got the clock down, then say, you know, please draw the hands at 20 to 4. But if they are impulsively going ahead and putting the hands in, that's interesting. It's not a quantitative finding, but it is a qualitative finding. Hey, did your clock look like this? That could mean that you have some spatial problems, perhaps a right posterior lesion. It might also mean that you have neglect, because you can't see this side. All right? Because a person with a lesion in the right posterior would draw a clock like that, looks like that. Because people with posterior lesions, especially parietal, have problems with planning and organizing. They also have problems with visual-spatial planning. Visual-spatial planning and organization. So it would look like that. And they also might have some left neglect. You remember the deficits will be on the left if the lesion's on the right. What about one of these? This is Alzheimer's. Anyone looks like that? Please say no. Okay, good. And then this one you can barely see, but the numbers are actually on the outside here. It's a reverse clock, which is also indicative of right hemisphere syndrome because of the planning piece. Yeah, fun, huh? Okay. If you're interested in clocks, there's actually a book. Oh, I can't believe, I think I just found it the other day, and it's not even a newer issue book. I think it was from the 90s. Type in Amazon clock drawing. There's actually a book out there that analyzes clock drawing. It's got like 100 different types of clocks, and you know what part of the brain is deficient or has a lesion if you find the clock. Apraxia, the inability to perform previously learned motor acts. So this results in brain damage to the motor strip, premotor area, temporal lobes on the dominant hemisphere. There's ideational apraxia, which is the inability to carry out hierarchical, complex motor plans. So you would ask them to show me how you make a bed, show me how you button your shirt. And if they're not able to do that, well, there's a problem. There's also constructional apraxia, which is the inability to form construction in space, such as copying a shape, aka figure drawing. Okay? Then there's oral apraxia, and this is one of the most predominant apraxias. It's also one of the most misunderstood because it's often misdiagnosed as aphasia. Mr. Cartwright, open your mouth. Stick out your tongue. Blow. All right. And you would go down the list just to make sure that they can do this. This is motor memory of your face. All right. For someone who has had a stroke, they might not be able to do this. And they might have a slurred speech, which someone says, oh, they're aphasia. When in actuality, it's not that part of the brain that's damaged. It's the part of the brain that has to do with actually creating the muscle memory for your face, like the motor strip, as opposed to Wernicke or Broca's area. So agnosia, the loss of ability to recognize objects, persons, sounds, shapes, smells, etc. There's many different types. Now agnosia shouldn't be misinterpreted as metacognitive awareness. Right, to appreciate and learn from your own ability to think or learn. Good. And I got in this huge, I don't know, philosophical debate. I'm like, well, isn't agnosia the same as metacognitive awareness? No. Agnosia is the inability to process facts, and specific to the fact that they have deficits and appreciate them. So someone who has a stroke or a psychotic disorder might not be aware of the fact that they have had a stroke, or might be aware that they have a stroke, but are not aware now that they have aphasia. You know, they're like speaking gobbledygook. They think that something's wrong with you for not being able to understand them. Okay? It's not denial. it's an actual physiological problem. Whereas metacognitive awareness is the ability to appreciate your style of learning and be able to learn to that